Thank you very much for this opportunity to introduce my work. Sorry, slide is in Japanese, but I want to speak in English. And the title says that the simulation, multi-thread simulation for the open source library Characterizer. And the contribution of this paper is proposing a characterizer named libretto. And in this library area, developer try to name his tool with lib something, liberate or liberty or something. And in this case, I named this tool as libretto. And this characterizer is developed with Python 3 and free NGSpice simulator. So everything is free. And this tool is available on my GitHub. And this characterizer can characterize a cell of combinational version and sequential one. And it uses truth table to implement his logic functions. And for the sequential cell, we have several sequential cells with set and reset, and this libretto can characterize these flip-flop with set and reset. And the main contribution is implementation in multi-thread to speed up the characterization, and it achieves 40.5 speed up based from the one thread simulation. And here is the outline, and I want to explain from the background. And the background is an open source VLSI design. And as we see at the booth of Ishikai, both the Japanese and also United States, these groups are trying to encourage the open source silicon design. And for the conventional one, we are using a commercial tool, and also we are using IP from Fab. But for this kind of open source to design, we are using open source EDA, and also we are using open source IPs to design our chip. But so basically everything is free, so we do not need to pay cost for free commercial tool. But the issue is some tool is not performance is not good, or sometimes the important tool is not available. And one example is the timing analysis. We say static timing analysis, STA. In STA, we want to measure the maximum delay from input to output to evaluate the maximum operation speed. To calculate this maximum delay, we need to calculate this max operation for each node. So to do this, we need two things. One is the computation engine. We need to take maximum of this delay. And the STA engine is available. But another question is, okay, how we measure this delay of each logic gates? And to evaluate the delay of these logic gates, we need characterizer. So here is the characterizer, and we have a characterizer. Characterizer extract the delay and power of this combinational cell and sequential cell. To do this, characterizer generate input of SPICE simulator. So it generates a SPICE file and launch SPICE and extract the result and accumulate this result and generate Liberty file. And we have several commercial tools of characterizer from, we can say, Synopsys, Cadence, and Silvaco. But issue is price, and price is very expensive. So we need a characterizer, but we have still we have no conclusion for this kind of open source characterizer. And here it shows a list of characterizers. Sorry, this is somewhat very old, but anyway, these characterizers has a pros and cons. For example, this one is a characterizer, but it uses individual characterization binary for different logic cell, or sometimes they are using commercial spice, means spice 3 or H spice or specters. So this is the main issue for this kind of open source characterizer. And sometimes the LC time is somewhat common in this field. But the issue is this LC time is a single thread simulation, so the characterization speed is not good. So again, this slide explains our contribution. Our characterizer libretto is designed with Python 3 and simulator is ngSpice, so everything is free. And also it supports logic cell, sequential cell, and to support more logic cell, this libretto is designed to enable the new cell by introducing the truth table. So if designer design his new cell, he can write its truth table to libretto, then libretto can extract the timing and power. And this version supports multi-thread, and it achieves 40.5 times speed up in 32-core environment. So this libretto needs two things. One is the netlist of target cell, and of course spice model is required. And to control this libretto, we need a control file. And libretto reads this file and executes spice simulation in parallel and extracts the result, and finally it generates a liberty file. And also for Verilog simulation, it generates Verilog model, and also it generates a data sheet of library in Markdown format, and it is converted to PDF. And this is somewhat detailed, so I don't want to explain in detail, but anyway, we have two common settings. One is the library name or unit or power. Second common thing is condition of process, voltage, temperature, and logic threshold is also needed to define. And then it simulates the cell in parallel, and also it supports two engines. One engine is for the combinational cell, and second engine for the sequential cell. The issue is timing, as ngSpice is very slow, and also Python is not so fast, so we need to speed up the characterization. And inside the characterizer, we have several parallelism, but in this libretto, it decided to unload the loop for condition level. Means the multiple load and multiple throw condition is available, so this part is unloaded. For example, in 180 library, it has 7 different load index, 7 different slope index, so we can easily extract 49 parallelism from this kind of input through slope conditions. For the implementation, we simply use threading of Python. So, and also we are using a bounded semaphore to control the number of threads. And here is the one result. In this case, we use 180 nanometer library for characterization, and red one is a libretto. This is our implementation. And if we use just one thread, then it needs 60 hours, so 3 days we need. But if we enable this multi-thread, then it achieves it needs just 4 hours, so 14.5x speed up. 4 hours is somewhat very huge, still huge, but it is okay because if we hit enter at the night, then this libret will give some result at the morning. So company person says that this is acceptable. Commercial characterizer primarily from synopsis, it achieves very, very fast because H-spice is very fast. And in this table, it says that we can gain 40.5x speed up in 32-core simulation because different cell has a different condition. So it is not, how can I say, this is realistic result, but it is not an extreme case. So next, I try to do the somewhat extreme case. So in this case, we use the same condition for all of the parallel cases. And in this case, it is clear that if the right-hand x-axis is the number of threads and y-axis is the speed up, in this environment is a 32-core 64-thread CPU. If we increase the number of threads, then we can gain more speed up, and roughly it saturates at 32. So it demonstrates that in ideal cases, it achieves full number of CPUs. Okay, so this is the end of my talk. Today I explain our open source characterizer for open source VLSI design, and it is used for timing analysis of digital circuit. And one thread simulation is too slow, so it is not acceptable. So we implement a multi-thread implementation and achieve 14.5x speed up, and now this timing is somewhat reasonable. Commercial one is very fast. Basically, commercial one is very, very nice. And still we have space to improve the speed, so this is our future work. And the tool is available in this repository, so if you have an interest, then please access. That's all. Thank you very much.
Thank you, Nishizawa-san. Thank you very much. Are there any questions and comments about this presentation?
Both Japanese and English is acceptable.
Yeah, actually it's great contribution to this open community, but accuracy of this characterization is the same as commercial tool?
For the combinational cells, the accuracy is somewhat close. But for sequential cell, the accuracy is not good. Because the algorithm to finding the minimum point is different. So I think this is one big reason that cannot achieve a good accuracy.
Okay, but yeah, I think the conservative assumption is very good in this sense.
Mm.
So, have you ever developed chips with this characterized library?
No. But I want.
Yeah, we expect. And well, actually, for me, there is a very important problem to that there are reasons this kind of characteristics and characterizer library. But well, without characterizer library, how chips can work?
Yes. We need the characterizer because we need to get. So it seems that they are using some pre-characterized library. Yes. But the issue is we cannot add new things, new cells. So we need a characterizer.
Okay, yeah, but using completely open source is very good.
Yes.
Thank you.
Thank you very much. Thank you for.
Okay, so
Yes. So 3:30.